Can you see my screen?
Yes, please.
Okay. I will start my presentation. Okay, so hello everyone, this is Dennis, and welcome to BMW Lab training course. And today I will introduce the ODU Max Scheduler. Okay, and for today's topic, first I will briefly explain what is the Max Scheduler and what is the purpose of the scheduler. Then I will introduce the functionality of the Orange scheduler. And the third part, I will show you how OSC scheduler do the uplink and downlink scheduling. And the next part, I will show how to configure the TDD pattern for OSC DU high. And this is our live today. Okay, let's start it for the introduction part. Okay. So what is the Max scheduler? Actually, scheduler in 5G network is used to allocate the limited resources for transmitting data, including the uplink and downlink. But what kind of resource to be allocated? This resource is called a physical resource block, and it usually abbreviates to PRB. It's basic allocating unit for the Max scheduler. And you can see the figure at right hand side. The green block means the resource block, and the resource block engages the 12 subcarriers in the spectrum or in the frequency domain. Okay, and so we know that the scheduler is used to allocate resource, and this resource is called physical resource block with engaged 12 subcarriers in frequency domain. But how does the scheduler do the scheduling? Actually, scheduler will get the information from the user, and this information is called CSI, which means channel state information. And it means the UE will report the CSI to the scheduler. In order to know the channel capability for each UE, then scheduler can refer to this information, CSI, to do the scheduling individually, according to this information. Okay. So the second part is the functionality of Orange scheduler. Okay, as this figure, you can see there are 8 submodules in Orange scheduler. Then I will introduce them one by one. The first one is resource scheduler. In resource scheduler including the downlink and uplink, and this submodule is used to do the time domain and frequency domain scheduling. Or you can say the resource scheduler is used to allocate the physical resource block I just mentioned before. Okay, and the next one is the link adaptation. This submodule is used to schedule the MCS for each UE according to their CSI, I just mentioned before, channel state information. And be aware of that each UE has different CSI. So each UE will be scheduled in different MCS. But what is MCS? MCS means the modulation and coding scheme. And this parameter can indicate that the modulation method and the coding method for each UE. And by adjusting the MCS, it will cause the different bit rate for each UE. Okay. And the next one is MIMO mode control submodule. It's used to schedule the MIMO mode for each UE, which means to schedule the antenna for each UE. And the next one is power control. It's only power control submodule, and it's only used in the uplink because this submodule will schedule the power for each UE when UE want to transmit the uplink data. And power control can also reduce the power consumption for each UE. And this submodule is the TA manager. A TA means the timing advance. So what is the timing advance? You can see this figure. this figure. Assume there are two UE, and UE2 is more far away from the base station, assume. And the base station will broadcast the message to UE1 and UE2. As this figure, you can see the UE2 receive the message after UE1 receives. That's because these two UE has different distance I just defined between base station. And cause UE2 receives the message late. This will cause the UE2 receive message late because of the distance. And in the perspective of base station, it wants to receive the uplink data from each UE at the same time. For the base station perspective, so scheduler will adjust the transmitting time of each UE according to the distance between UE and base station, and it's called the timing advance. So the TM manager is used to estimate the timing advance command. Okay, so far I have finished to introduce the functionality of Orange Scheduler. We found that each submodule is all related to scheduling this word, like scheduler resource, scheduler MCS, scheduler power, and actually each submodule has the specific algorithm to deal with the problem. If you are interested in this, you can also develop the algorithm for this module. Okay. And this part is about the make to scheduler or scheduler to make API, this API. As you can see this figure, you can only communicate with make scheduler via the make. And that's why it needs to define this API. It's also convenient to plug in the scheduler implementation for the vendors or operators. And this API are also well defined in the Open RAN working group at AAD, this specification. Okay, and the next part is the uplink and downlink scheduling methods of OSC scheduler. Okay, at this page, I will show you that how OSC Max scheduler do the uplink scheduling. And you can see this figure in the left-hand side, this figure. Assume this UE wants to transmit the uplink data to the base station. The first thing is to send the scheduling request to the base station. To let the base station know that this UE wants to transmit the uplink data. Then GNOB will send the uplink grant to this UE to act this request, to act this scheduling request. Okay, after that, GNOB will send the uplink scheduling information to UE, and UE can transmit the uplink data according to this information from GNOB. But GNOB doesn't know that how much data does this UE want to transmit. It means GNOB has no any idea to allocate the resource to this UE. So UE will transmit the BSR and PHR first, and the BSR means the buffer status report, and it indicates the amount of data which UE wants to transmit. This parameter indicates that. And the PHR is the parameter which is regarding to the power control. Okay. Now GNOB want know the amount of data, so it can allocate the resource and send the uplink scheduling information to this UE. Then UE can transmit the data according to this information because GNOB has allocated the resource to this UE, and UE will send the uplink data to the core network or end-to-end. Okay. As you can see, this figure in right-hand side, I also show that what is make and scheduler doing when UE and GNOB do the uplink scheduling, do the uplink transmission. and I also match them one by one. When UE transmit the scheduling request to GNOB, and then to the MAC layer, it will build and send the scheduling request indication to the scheduler. And scheduler will do the things below, like the downlink scheduling information. And these are all defined in the make and scheduler API I just mentioned before in the Oren working group at AAD. Okay. And for the downlink scheduling, GNOB will allocate the resources for downlink according to the CSI, the channel state information of UE, and then it will send the data to UE directly. And for the OSC MAC and scheduler part, the MAC layer will get the data from the ILOC layer, then transmit it to the scheduler, which is called the downlink ILOC buffer status information. Then the scheduler will allocate the resource for the downlink data. And this is the downlink scheduling. It is much more easier than the uplink scheduling. Okay, then I will introduce how to do a TDD pattern configuration for the ODU high. Okay, and before we talk about that configuration, we need to know what is the FDD and TDD. And as a figure, you can easy to understand. The FDD means it will split the uplink and downlink by different frequency band. And the TDD, time division duplex, will split the uplink and downlink by different time slot. And then I will show how to configure the TDD pattern. TDD pattern means the first one slot, do you want to put the uplink or downlink? The second time slot, do you want to put the downlink or uplink? And it can configure it. It can be configured. Okay, and here I will show you how to configure the TDD pattern. And as this frame below, you can see each frame has 10 slots, and each slot has 14 symbols. Then let's follow this configuration to fill the TDD pattern. We can see here are 7 downlink slots in this macro define. And so we need to fill the downlink slot from the beginning. Like we have 7 downlink slots, so 1, 2, 3, 4, 5, 6, 7. Okay, and then here are 2 uplink slots, so we can fill it from the end. The 1, 2. Okay. As you can see this figure, we still have 1 slot haven't been filled. This slot, and how can we fill it? We can use these 2 macro to fill it. Like the we can also start it from the downlink symbols, and we know each slot has 14 symbols. So we just follow the things we just do it. The downlink symbol will go first, like 1, 2, 3, 4, 5. Okay, and the uplink will fill the slot from the end, 1, 2, 3, 4, 5. And there are the pink part or red part left here, and we usually call it the guard period or the flexible period. And that's how we configure the TDD pattern in the DU high. And this configuration file is in the L2 source code and DU app folder and DU config.header file. Okay, and that's all. Does anyone have any question?
Thank you, Dennis. May you go to the scheduler for OSC?
You mean this part or?
No, first of all, the last figure. Like No, go to the end, the last figure, the last page. Yes,
This one.
here
Okay.
I suggest you to show us where is 2 and the 5 for the start symbol. I means you have 4 parameter. Try to
Yes.
show us the meaning directly on your figure.
Okay.
Okay. You can revise the slide later
Okay.
on, so it will be more clear to everybody.
Okay. Thank you.
And go back to your scheduler. Now I would like to know. Yes. So from the right hand side,
Yes.
this is the implementation from OSC now,
Yes.
right?
Yes.
So they already split the Mac and the scheduler. Because in the early version they are mixed up together. So I don't know whether this is what's the version you are referring to, release E or
I refer the master branch. Maybe you can call it F release.
F release.
Yes, because
Okay,
I did clone the master branch.
okay. So maybe you can check it with Tony. As I
Okay.
remember, release C they don't split the
Okay.
schedule at that moment.
Uh,
So at that time, Jonathan originally he want to develop some new scheduling algorithm, but cannot do it.
okay.
But Redis is told us they will split it later on.
Okay.
So please check it with him.
Okay. I will check
And
it.
what are the scheduling algorithm do they provide at this moment? If you remember, in Yue Huan's talk, the rig test, they implement 2 kind of the scheduler.
Yeah.
So I don't know what kind of scheduling algorithm do they use. Is round robin or weighted round robin or what?
I remember they have two, at least two as I remember. The one is round robin and another one is I don't know how to call it, but it's just like when
Is it the same as Yue Huan? Yue Huan, what are the two type of scheduler provided by rig test?
As I remember, is a proportional fair and the
Proportional fair.
yes
this
that
one.
one.
Okay, so
Okay.
they are the same. Okay, thank you.
Yes.
So may I ask? So these two kinds of algorithm can support both downlink and uplink?
Can they support the downlink and uplink?
Yes, because as I remember, proportional fair only supports the downlink for rig test. So
Sorry, maybe I haven't traced to that. Maybe I can check it later.
okay. So
After.
may I ask some questions?
Okay, sure.
The first question is from a previous slide, I see Jackie shows Mac has a Mac and a lower Mac.
Yes.
So why do they want to split this?
The lower make is mainly deal with the about the FAPI interface. The lower make.
So it's just to focus on handle the FAPI interface message.
Yes.
Okay.
Yes.
Okay. So another question is about the page 9.
Page 9. Okay.
Okay. So if you want to send something to Geno B, they need to use uplink scheduling, right?
Yes.
But how does UE transmit the scheduling request? Because at this moment, UE don't has the opportunity to transmit, right?
Yes. The scheduling request is is only engaged 1 bit. So
Oh, okay.
I think it can transmit at any time after then did the random access.
So which channel do you use schedule request?
Which channel do you wait a second. I remember is PUCCH.
Okay. Common channel.
Yes.
Okay. The last question is page 13.
Page 13. Okay.
Okay, so this figure shows the format, time slot format, right?
Yes.
So it's only for time domain division. So frequency domain division doesn't need this this format, right?
Yes, because the
Okay.
frequency.
So
Yes.
currently, this ODU can support the spatial time slot.
Spatial time slot.
Yes.
What do you mean for the spatial time slot?
Yes, I think the spatial time slots is just look like both in a time slot it both support the downlink and uplink.
Oh,
VDMA or
um,
Oh, it's just like you show this figure. So these slots.
oh, I know what you mean because I have seen that in the LT TDD pattern, but in the 5G pattern, I'm not sure because for this configuration file, it can only adjust like this.
Okay.
So this part, I'm not sure.
Okay. So it's just for a frame, the whole frame, right?
Yes.
Okay. Thank you.
Thank you.
Let
hi,
me give a quick
sorry.
comment. The configuration should be sent from the O1 interface. So this is a hard configuration we use in ODU now, but I think this configuration finally they will be configured by SMO and transmit here. So we need to know how to change this kind of parameter.
Yes.
Yeah.
Yes. Okay.
Okay.
Thank you. And
Hi, Dennis.
okay. Hi.
I have a question. I saw a document before, and it mentioned, it is possible to dynamic adjust the modulation method, but I think as I just saw, I think it can only adjust the parameter or about modulation.
You mean the MCS?
Yes.
So you you saw spec before it state it can change anytime or
It is not go deeper, but so I just want to ask you. Yeah. Do you think it is possible or?
I think it's possible because the link adaptation is used to adjust the MCS for each UE.
Also, although we can adjust the parameter, maybe like the number of downlink slot, but we cannot modify the whole modulation method.
Whole modulation method.
We can change the modulation scheme and modulation and coding scheme. We can change the modulation MCS. This is done by the link adaptation module mentioned by Dennis.
Yes.
Oh, okay. Okay, thank you.
It can be changed over time based on the CSI of the UE.
Yes.
Oh, okay, I got it.
Okay, so does anyone have any question?
Hi, Dennis. I have another question. Okay. About the page 9.
Page 9.
Yes.
Okay.
About uplink scheduling. Scheduling request. You mean we only transmit one bit to GNOB. But
Uh,
how does GNOB identify this UE? And is it possible to be collision?
I think scheduling request will let me think. I know they will transmit the follow the how to say follow the start notification. Every start notification it will send this message, but for the collision opportunity, I'm not sure, but in my opinion, I think it may happen. Random access.
Or GNOB just use polling to list UE?
I think it's possible, but I'm not sure.
Okay. It's okay. Thank you.
Try to check the spec
Okay.
and share technical note.
Okay.
Then you can find the answer.
Okay. Okay. All right. So does anyone has any question? Or I will start my sharing. Okay. Thank you, everyone.
Okay. Thank you, Dennis.
Okay. Basically, the GNOB will allocate a resource for the UE to send the scheduling request.
Oh.
Detail, I guess Dennis can check it. It will not have collision for
Okay.
this
Okay.
part.
Okay.
Collision occur only in random access during
Okay.
the random access.
Okay. Okay.
Okay.
I
Thank you.
got it. Thank you. Thank you.
Thank you very much.
Thank you.
Okay, so I think it's almost